Okay, in this presentation we are going to look at the Pareto Type 2 distribution, and this is an insurance industry application. Okay, so for a large portfolio of insurance policies, losses follow a Pareto Type 2 distribution with a shape parameter alpha equals 3.5 and a scale parameter theta equals 5,000. Now let's just think about what we're talking about here, losses. Okay, some incident has happened and it's going to cost money to replace that or rectify it. Okay, so that's what we mean by a loss. So if you damage your car and you have to spend €300 or something like that, that is a loss. Okay, so that's what a loss means here. Okay, now an insurance policy covers losses subject to an ordinary deductible of €500. Okay, so if I'm an insured person and the loss to me is €400, it's not worth my while going to the insurance company because I have to spend the first 500 of the loss myself, and I only get insured for value or the damages and costs in excess of 500. Okay, now given that a loss has occurred, okay, determine the average amount paid by the insurer. So if the cost is less than 500, the insurer doesn't have to pay anything, so the cost there is zero. If the cost is greater than 500, let's say 750, that means the insurer has to pay out 250. So it's both. This question covers both of those scenarios. Okay, the average amount paid out by the insurer. So it's slightly a trick question. Okay, so let X be the overall cost of the claim, no matter who pays out, the insured or the insurer. D is the deductible to be paid by the insured. L is the cost of each claim to the insurer, so L is X minus D for X greater than or equal to D and 0 otherwise. Okay, so it's essentially, by the way, we're just working on the basis that these are continuous probability distributions, so we're assuming that these are complements of each other, just a sort of notational question. And what we're asked to do is compute the expected loss, okay, to the insurer. So how much this costs to the insurer, that's what we're asked for. L is slightly misleading there, but L is the cost to the insurer, okay? The insurer's loss per claim. Now, when the nominal claim amount is less than the deductible, X less than or equal to D, essentially the no payment is essentially the answer, okay? The insurance company doesn't pay anything, zero. Okay. Now, what's the probability of this happening? This is where we would sort of rely on the cumulative distribution function. What is the probability that X is less than the deductible? So what we're going to do here is go to our cumulative distribution function, 1 minus 1 plus X over lambda to the power of minus alpha. Okay, so we're going to use that. We're going to put in our values there, 1 minus 1 minus X to the power over lambda to the power of minus alpha, 1 minus 1 plus 500 over 5,000, okay, to the power of minus 3.5. Bit of calculator work, that should be around 0.28364%, or 28.36%, okay. So that's done. So the second thing is, well, actually, what we can deduce from that is the probability of it being excess of that is 71.6%, something like that. We'll come back to that shortly. Now, this is where the trick question comes in, because this is what you might feel like you're being asked, but it's and I think this is all that you're asked for in the question: the mean excess loss. This is how much the insurer will pay out on average on each claim, given that the claim has gone above a threshold. It's a conditional expectation. Now, I'm not going to deduce this, so take this as a sort of standard result that we can just sort of invoke here. Let's just say it's at the back of your exam paper or something like that, or in your tables. Okay, so I'm just going to use this formula. Now, this is for the type 2 distribution, by the way. If it's a type 1 distribution, there's a variation of this. d plus theta divided by alpha minus 1. Okay? So let's just calculate that. 500 plus 5,000 divided by 3.5 minus 1. That's 5,500 divided by 2.5, which is 2,200. Okay. Yeah, that's it. Just to recall, that's a type 2 distribution. So if it's a type 1 distribution, we would use something else. Okay? Now, of all the incidents that occur, the insurance company will only get involved with 71% of them. In 28%, the claim amount is just below the deductible, so they're not going to pay out. Okay? So 71% they will have to pay out, and on average, that's the cost of the claim. There. Okay? So that's essentially what we're asked to do, calculate that. So basically we have two scenarios. It's less than the cost. It's the cost of the claim is less than the deductible, and that just goes to 0. And in this instance, it's greater than the cost of the expected value of loss, given that it's greater than the deductible. That's 2,000 divided by 2,200 times 0.7164, and that is that value there, 1,575.97, give or take a bit of rounding error. Okay, that's how much for each person insured. That is how much we expect to lose on all of the claims. Okay, so that's different from this. This is what you're usually asked. This is sort of a variation on this question. Okay, so that's great. We'll leave it there.